Alright, question 47. You want to invest $10,000 and you have three options. One account offers you an interest of 6.6% compounded biannually, another 6.55% compounded quarterly, and the third 6.5% compounded monthly. Which one is the best option if you want to leave your money in the account for 5 years? Okay, let's look at that. So three options. It's all based on the formula. You have to know it, okay? So the amount after T years, in an account is the original amount times, okay, so 1 plus R is the interest rate in decimal, of course, divided by the number of times you're compounding that a year, to the power of, well, the total number of compounding, which is N a year times T, the number of years, okay? So this is when you compound N times a year. The other formula, I'm not sure why I didn't answer the question here. I'm a bit surprised it should go there. The other formula is, okay, so what happens when you compound continuously? And that's a formula when you compound continuously, right? A naught E R T, which actually also, this formula refers in general to anything that grows or decay. Okay, in general, growth or decay goes like this, right? EKT for growth, or P equals P naught E negative KT for decay. Okay, for decay. I invite you also to look at the here the doubling time, and here it's called the half-life. Okay, so I invite you to look at all of that. K is positive always, okay, K is positive here, and K is also positive here, that's why we have a negative sign, okay? So just check all of that. So basically these three formula are really just the same thing, right? I mean, it's a model for growth or decay. This one and this one, same deal, okay? Something is growing, all right? Okay, all right. So let's do it. So we have, for the first choice, so I'm going to call that A1 of T, is, so 10,000 times 1 plus, all right, so it's biannually, so I know twice a year, so N is going to be 2, and the interest rate is 6.6%, so 0.066, right, 6.6%, times 2T, right, and then right here we will want, I'll plug that in the calculator, but right here I will want A of 5. A of 5. I'm sorry, the A1. This is the first choice, A1 after 5 years, okay? And we will want to know what that is. Guess I'm gonna erase that. Don't have enough room. Make sure you look at all that stuff, right? I don't think I've asked any question for doubling time or half-life. It's part of this model. Okay, all right. I'll do that after. Let me write the equation first. A2 of T is 10,000. Okay, this is really bothersome. Ugh, stupid computer. Times 1 plus, okay, what's going on in the second option? The second option is 6.55%, 0.0655 divided by Quarterly. Quarterly means 4 times a year, right? To the power of 14. And we'll look at A2 after 5 years. Okay. And finally, the third option. The third option is A3 of t is 10,000. And the third option, I know it's monthly, right, I believe. So it should be a 12 here. And the interest rate is, yeah, monthly, 6.5. So you see, the interest rate here, they're getting slightly lower, right? But then the number of time you're compounding is getting higher. So I'm reducing the interest rate, 6.6, 6.55, 6.5, but the number of time I'm compounding is increasing. So we'll see what happens to the amount after 5 years, okay? And that's my third option, and it's after 5 years. So I'll take my calculator now and just plug this function. Okay, so 10,000 times parenthesis 1 plus 0.066 divided by 2, close the parenthesis, to the power of 10, right? 2 times 5 is 10, to the power of 10. And this is about 13,835.8, and it's dollars, okay, or rather 80. We should write to the hundreds. Okay, second option, my interest rate is now 6.55, okay, and it's 4 times a year, and it's going to be to the power of 4 times 5, 20. It's going to be to the power of 20. And here I have 13,838, oh, it's really close, 0.20, and it's all dollars. And the last one, so it's 6.5%, 12 times a year, and this time it's going to be to the power of 12 times 5, 60. And here it is 13,828.20 again. Okay, so the best option is option 2, and option 2 is 6.55% quarterly. That's the best option. Okay, all right, so you need to know this formula. Next problem, sequence of transformation. So this is about graph shifting. Indicate the sequence of transformation from the graph of y equals 2x to the graph of f of x given right here, and graph f precisely in the given system of axes. You must clearly indicate the asymptote and use at least 3 points. Okay, so all right, so we'll see. So I'm starting with y equals 2x, and I go to, okay, oh my gosh, y equals 2 to the power of x minus 2. Okay, that's the first one. I will indicate the name after. The second one, well, actually, should I? Yeah, I'll have enough room right here. The second one would be y equals, all right, so what do we do? X minus 2, then we multiply by 3. 3 times 2 to the power of x minus 2. The last one, so you need to know the order of graph shifting. There are notes online in the course website. I don't remember, I think it was in Unit 2 maybe, I don't remember. But it is first semester material, but it's something we use all the time, okay? We don't have in math only asking question about the second semester. That doesn't make any sense in math, okay? We need this material all the time, so if you want to review that, check out the first, it's going to be in the first, I think, first semester. Yeah, it is there. 2x minus 2, and then it's minus 4. Okay, all right, let's indicate what each transformation does. The first one is a horizontal translation, and let's be more precise, 2 units right. Okay, it's counterintuitive. The second one, if you subtract x, you go to the right. It's counterintuitive. The second one is a vertical dilation. It gets bigger, so it's a dilation. When it gets smaller, it's a compression. By a factor, multiply here by a factor of 3, or multiply y by 3. And the last one is it's a minus 4, so it's a vertical translation again, and this is 4 units down. Okay, let's graph everything. So we start with y equals 2 to the x, right? Okay, you're supposed to know how to graph that. 2 to the 0 is 1. 2 to the negative 1 is 1/2. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. And I don't think I have more room for the next one, that would be 16. Okay, that's 2 to the x, and then after I'll multiply by 3. So let me graph this right here. So that would be pretty... You know the y-axis, I'm sorry, you know the x-axis is the asymptote. So of course I don't like this part right here, but the rest is pretty good. The x-axis is the asymptote to the graph. You follow this, like that, and here like that. Okay. Okay, good enough. So that's y equals 2 to the x. Second one, we are moving 2 units right. Okay, so 2 units right. Take all the points, move them 2 units right. Okay, let's graph again. Try not to go below the x-axis, right? It doesn't go past the asymptote. Actually, it never normally touches the asymptote. Didn't get that. I guess the inconvenience of this video is you witnessing how meticulous someone can be, huh? But then to do math, you have to be meticulous a little bit. x minus 2. Okay, the next one, let's pick a color, green. Next one is you multiply the y's by 3, so I'm going to lose some points here, right? This y right here is 8 times 3, 24, I've lost. This y is 4, 4 times 3, 12. Oh, I'm barely there. Right here, right at the edge. This y is 2, 2 times 3, 6. Right here. This y is 1, 1 times 3, 3. And 1 half times 3, 1, 2, 3, 1.5 right here, right? Okay. Actually, here I had a 1/4. So right here we'll have a 1/4, so I can put it as 1/4 times 3 is 3/4, right? There's another point that would be right here. Hey, I'm asking you for 3 points, so don't worry about too much detail here. Okay, so here we go. Okay. All right. I'm not speaking very much today. 4 units down is the last graph. So here we go, 4 units down. So 1, 2, 3, 4. 1, 2, 3, 4. Oh, I'm right on top of this one. 1, 2, 3, 4. Okay, so 1, 2, 3, 4. No, there's yeah, it's fine. Because I'm 1.5 above the asymptote right here, so I'm 1.5 above the asymptote, and this one would be like somewhere here. But anyway, what's really important right here for you is to make sure you grab the asymptote. Okay, the asymptote is always okay. We've seen that in class. This is always where the horizontal asymptote is going to be. So it's a -4. So let's take purple. Okay, and let's graph. Okay. Oh, it's right here. And that, of course, is my final graph, right? So this is y equals 3 times 2 to the x minus 2 minus 4. Done! All right. Next question. That's probably not here. probably should go below, right here. Justify why f is 1 to 1 and oh, look at that. A field of stylus dropout. Here we go. All right. So justify why f is 1 to 1. Well, hey, there's only one justification. I mean, it's not true. We could do it analytically, but the easiest way to justify is graphically. F is 1 to 1 because it passes the horizontal line. Ooh, I gotta be careful here. If it erases everything, it passes the horizontal line test. Okay. So let's make it clear. F is 1 to 1 because its graph passes the horizontal line test. Horizontal line test. Okay, that's why. All right. Second, find the inverse. So you remember what to do, right? You write the expression, you switch x and y, and you solve for y. So let's take it right there and solve for y. So the first thing I'm going to do right here is add 4. Then I'll divide by 3. Then I can take the ln right here on both sides, okay? I can take the ln on both sides. Or I can use also log base 2 and write the log form. I'm going to use the second case. I'm going to write log form. Therefore, I'm going to use log base 2. It's the same if you take ln, except that you won't have the log base 2. You would find log base 2 if you were to use change of base. Okay, so log form. Actually, I'm also going to switch. I'm going to put my y right there, right? Y minus 2 is the log base 2 of x plus 4 over 3. And so the last thing we need to do right here, I guess I'll do it here. It's y equals log base 2 of x plus 4 over 3 plus 2. Careful, they want the inverse, so don't forget the last step. F minus 1 of x equals log base 2 of x plus 4 over 3 plus 2. Okay, you have to write the inverse. You cannot leave it like as y. I don't see. The corrector has to clearly see where you enter the question, even if he doesn't understand math, okay? Or she. Okay, alright, let's erase all of that. So in this question, right here. In this question, we're supposed to graph, you must clearly indicate. So listen, to do that, I am not gonna look at this in graph, okay? No way. What I'm gonna do is I'm gonna pick up the points that I had right here. This one is a good one. This one is a good one. I don't know, we'll see about these two right here. We have this one right here. And we have this one right here. And I'm just gonna flip the coordinate, right? And also, of course, and also the asymptote. Let's start with the asymptote. This equation, this is the asymptote of equation y equals -4. Therefore, when I'm going to flip my x and y, or reflect across the line y equals x, it's going to become x equals negative 4, right? Okay, that's what the asymptote becomes. A horizontal line becomes a vertical line. Okay, now let's pick some points. And the points are, alright, so nice one right here. 2, negative 1, right? Therefore, 2, negative 1 becomes negative 1, 2. Negative 1, 2, right here. Another one. 3, 2 becomes 2, 3. So it becomes 2, 3 right here. Another one. So this is 4, 8. 4, 8. So that becomes 8, 4. 8, 4 right here. Okay, right here. Now let's see if I can play with the 2 points that are not integer coordinate. This is 1, negative 2 point. This was a 0.5, right? Yeah. 1, negative 2.5. So negative 2.51. Negative 2.51 right here. Okay, and the other one actually was right there, I believe. Let me make sure. I'm not sure actually. Yeah. See, the x is 0, therefore the y would be 0, and it's 3 1/4, negative 3 1/4. So I'm going to x is negative 3 1/4. Yeah, okay, that's it. All right, that's it right here. So now let's graph it. Aye. You gotta feel the start. If you don't feel it, it's gonna be, maybe I need to move it up a little bit. Here we go. If you make a noise with your mouth, you will realize that you can graph better. Try it. Okay, how many of you tried it? You really believe everything a teacher tells you, huh? Okay, all right. I know you've tried it. I see you becoming red. X plus 4 over 3 plus 2. Okay, here we go. And I think I'll stop right here, this one, and I'll create another video after.